Hi, everybody, it's Professor Mitchell, and we have finally reached the end of Chapter 6. So today we're going to talk about Section 6.7, which is quadratic equations and problem solving. Only one objective in this section. We're going to solve problems that can be modeled by quadratic equations. All right, so I've got three examples here for you. The first example says a hang glider pilot accidentally drops her compass from the top of a 400-foot cliff. The height h of the compass after t seconds is given by the quadratic equation h equals negative 16t squared plus 400. And the question is, when will the compass hit the ground? So this problem always makes me laugh, believe it or not, because it reminds me of a book that I taught out of years and years and years ago. And it was basically this same problem, except instead of dropping a compass off a cliff, it was somebody throwing an engagement ring off a balcony. So I always appreciate some high drama in my word problems. But anyway, basically the same problem. So in this section, you're going to see me going back and forth between the presentation and the tablet, because I think that'll be easier to follow for these word problems. Okay, so I've drawn my version of the picture. That's about as best as I can do. And I've copied the formula that they gave us. So that problem might sound a little complicated, but it's actually pretty easy because they gave us a formula. Any problem where they give you a formula is going to be easier than one where they don't give you the formula and you have to come up with it yourself. So I think you're going to see an example or two of that after this. All right, so what I want you to think about is the formula says that the height of the compass after t seconds is given by this equation. And the question is, when will the compass hit the ground? In other words, at what time? All right, so in this problem, we need to find t. Okay, now if we're finding t, that must mean that either we know h or we know how to figure it out. Okay, so what is the value of h when the compass hits the ground? All right, down here. At the top of the cliff, it's 400 feet. At the bottom of the cliff, the height is 0, right? Okay, so in this problem, we want to find t when h is 0. All right, so just substitute 0 for h. And you get the quadratic equation 0 equals negative 16t squared plus 400. So now we think back to the last section. That's where we talked about how to solve quadratic equations. So the first thing I always do, which involves factoring, right? So you look and see, is the equation in standard form? And in this case, it is. I know we usually talked about putting the 0 on the right-hand side, but that's not, that doesn't matter. This is in standard form. So now we're going to factor what's on the other side. And I guess while I'm at it, I'll go ahead and switch the two sides. So what I'm going to do with this negative 16t squared plus 400 is I'm going to factor it. And you know the first step in factoring is always to look for the GCF, right? So in this case, I think we can pull out a negative 16. Remember when your quadratic polynomial starts with a negative number, we often think about factoring out a negative number. So we're going to factor out negative 16. And that's going to leave us with t squared minus 25, right? Oh, and by the way, when we get to chapter 11, I'm going to show you a different way to solve an equation like this. using something called the square root property. I think it's a little easier for this particular kind of quadratic equation, but in the meantime, we can use factoring. All right, so t squared minus 25, that looks familiar. We know that'll factor into, let me just put a line here. We know that'll factor into t minus 5, t plus 5. Okay, so now if something times something times something equals 0, we talked about that in the last section. That means that one of those somethings is 0. And this is something we should talk about at some point right here. A couple of different ways you can think about that. Okay, just barely had enough room for that. Okay, so the negative 16 equals 0. We can just ignore that because negative 16 never equals 0, right? So that's not going to give us any solutions. Of course, if t minus 5 is 0, that means that t equals 5. And if t plus 5 is 0, that means that t equals negative 5. All right, so now what was the question again? The question was, when will the compass hit the ground? After how many seconds? Well, I don't think both of those answers make sense, do they? It makes total sense for the compass to hit the ground 5 seconds after it's dropped. It doesn't make any sense for it to hit the ground negative 5 seconds after it was dropped. So we can ignore this solution. This is what we call an extraneous solution. It's a perfectly good solution for the quadratic equation, but it doesn't make real life sense, okay? So often when we do word problems, we're answering the question, how many or how much of something? And I'd say the vast majority of the time, that's not going to be a negative number. So I'd say at least 9 times out of 10, when you get a negative answer to a word problem, it is usually an extraneous solution and you can ignore it. But, you know, think about it in terms of the original problem, just to make sure. All right, so this problem has only one good answer, and that is the compass will hit the ground after 5 seconds. I always like to write a nice English sentence as the answer to a word problem. The question is in everyday English. The answer should be in everyday English. All right. So let's go back to, hold on, hit the wrong button. There we go. Okay. Second example. The height of a triangle is 2 millimeters less than the base. If the area of the triangle is 60 square millimeters, find the base. In other words, find the length of the base. So I just want to point out, it was very nice of them to draw this picture. They didn't have to do that. And you'll see in other problems, they won't draw the picture. They'll leave it up to you to do that. All right, so I have copied this picture onto the tablet. So let's go back there. All right, I think this picture is pretty decent. It's better than my cliff picture. All right. Okay, so the area of the triangle was 60 square millimeters. So think, you know, back into your memory. How do you find the area of a triangle? Do you know that formula? It's area equals 1/2 base times height. Okay. So at this point, a student will often stop me and ask, Mitchell, do we have to know all these formulas or are you going to give them to us? So since you're an online class, what I'm going to say to you is any formula that you encounter doing the homework is fair game for a quiz or an exam. So you might want to start making a list of formulas. You may already have one started, right? Sum and difference of cubes from section 6.5 is one example off the top of my head. All right. So we want to find the length of the base of this triangle. And we're given that the area is 60. And we're calling the base x, and we're calling the height x minus 2. So there we go. All right, now believe it or not, that is a quadratic equation. I think the first thing I'm going to do is let's get rid of that 1/2. And the way that I'm going to do that is I'm going to multiply both sides of the equation by 2. So this 2 will kill this 2. And you know what, while I'm at it, I'm going to switch the sides of the equation. So now the left side will become x minus 2, and the right side will become 120. That looks better already. So of course, the reason this is a quadratic equation is because when I distribute this x, that's going to give me x squared minus 2x. And then to put it in standard form, I'll just subtract 120 from both sides, right? And that'll give me x squared minus 2x minus 120 equals 0. All right, so this is the kind of equation that we solved in the last section. We'll solve that by factoring. So I just need two numbers that add up to -2 and multiply to -120. If you think about that for a minute or so, hopefully you can come up with -12 and +10, right? All right, so if x minus 12 times x plus 10 is 0, that means that x minus 12 is 0, or x plus 10 is 0. If x minus 12 is 0, that means x equals 12. And if x plus 10 is 0, that means x equals -10. And of course, the base of a triangle can't be -10 millimeters. So that's another one of those extraneous solutions. So the base of the triangle is 12 millimeters. Okay. So far, so good. Hopefully that doesn't seem too horrible. All right, back to the presentation. I just have one more example. And every time I see this example, I think of a class I had many years ago. So this problem says to find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg. So we're going from a little itty bitty triangle to a great big one. 10 miles more than the shorter leg, and the hypotenuse is 10 miles less than twice the shorter leg. So many, many years ago, I was teaching a class just like this one over at Stanislaus, actually. And I put a problem like this on the exam, and it didn't go over very well. And what I realized, and I actually felt a little guilty about it because we hadn't gone over a problem like this in class. Hopefully I had assigned it in the homework, but we never went over it in class. So ever since then, I've always done an example like this. All right. So one last time, back to the tablet. Oh, not yet, not yet. I just remembered I'm doing this a little differently. Okay, so let's see. Find the length of the shorter leg of a right triangle. So some different strategies for word problems. One of them includes, of course, look at what they're asking you for. And I'd say about 5 times out of 6, you're going to name your variable after what they're asking for, okay? And this is one of those times. They want us to find the length of the shorter leg of a right triangle. So why don't we call that x? And then they go on to tell us that the longer leg is 10 miles more than the shorter leg. The longer leg is 10 miles more than the shorter leg. So that means the length of the longer leg is x plus 10. And the hypotenuse is 10 miles less than twice the shorter leg. So that makes the length of the hypotenuse 2x minus 10, right? Okay, so now we can go over to the tablet. Figured it'd be easy enough to get that part out of the way on the presentation. All right, so here is a picture of my right triangle. The shorter leg is x, the longer leg is x plus 10, and the hypotenuse is 2x minus 10. All right, so I've gone over this problem in every face-to-face Math C class I've done for many, many years now. And often it's a little bit of a challenge to get people to see what formula we should use here. Even though this is a triangle problem, we're not going to use area equals 1/2 base times height because this problem doesn't say anything about area, right? So the key words in this problem are right triangle. Is there a formula or an equation for right triangles that I can use to link those three sides together? All right. So when I start drawing this little picture, I can probably trigger something if I start labeling these sides A, B, C. All right, you know what I'm thinking about? I'm thinking about the Pythagorean theorem, the thing that says a squared plus b squared equals c squared. That only works for right triangles. All right, and that's how we're going to find x. So when I replace a, b, and c with x, x plus 10, and 2x minus 10, I get x squared plus the square of x plus 10 equals the square of 2x minus 10. All right, so that's the equation we have to solve, and it is a quadratic equation. I see an x squared there. All right, so we have to start working on putting this thing in standard form. All right, so first let's multiply out the x plus 10 squared and the 2x minus 10 squared. So we'll keep this x squared, and then when I multiply out the square of x plus 10, I get x squared plus 20x plus 100. So if you need a minute to think about that, pause the video, and probably you could just FOIL x plus 10 times x plus 10. Okay. All right, and then the same thing with the square of 2x minus 10. When I square 2x minus 10, I get 4x squared minus 40x plus 100. Okay. All right, so now I'm going to combine my like terms. I see a couple like terms over here. So that's going to give me 2x squared plus 20x plus 100 equals 4x squared minus 40x plus 100. All right, so now I just need to get everything on one side. And what I would suggest, just in general, when you're working with a quadratic equation that has x squared terms on both sides, you might want to think about, you know, because it doesn't matter whether you move everything to the left side or everything to the right side. So what I would suggest is, like in this case, since 2 is smaller than 4, I would subtract 2x squared from both sides, and then my coefficient on my x squared term is going to be positive. So that's going to make it easier to factor. And so that means I'm getting rid of this, so I might as well get rid of everything else on the left side. I'll go minus 20x minus 20x. And then I'll go minus 100 minus 100. All right, so nothing left on the left side, just 0. And on the right side, I have 2x squared minus 60x. Oh, and look, this cancels. I wasn't planning on that. All right. I think I'm going to start a new page here. Might as well. This is the last example. So we have 2x squared minus 60x equals 0. All right, so that's a pretty easy quadratic equation. I'll start with my GCF, which is 2x. And that's going to leave me with x minus 30, right? Equals 0. So if 2x times x minus 30 is 0, that means either 2x is 0 or x minus 30 is 0. If 2x is 0, that means that x is 0. And of course, if x minus 30 is 0, that means that x is 30. Okay, so I don't have any negative answers. Do both of those answers make sense? Well, I bet the 30 does. What about the 0? Let's see. Let's look at that picture again. If x was 0, well, that would be kind of weird, right? Because it would make this side 0. I'm picturing like a very, well, not very, I'm picturing a perfectly flat triangle. But what's even worse is if x was 0, that would make this negative 10. So that's not going to work. However, if x was 30, that would make the shorter leg 30, it would make the longer leg 40, and it would make the hypotenuse 2 times 30 is 60, 60 minus 10 is 50. And that does make sense. So in this case, 0, even though it is my favorite number, it is an extraneous solution. And the only good solution is 30, which means the shorter leg is 30 miles. All right. And guess what? That's going to do it for section 6.7, and that's going to do it for chapter 6. So we will see you next time to start chapter 7. Take care.